All right, ladies and gentlemen, we are all the way to our Unit 5 review. I know you're just about ready and ready to get done with this, so let's get to it here. All right, first part, simplify each expression completely, show your work. Remember, the golden rule of factoring applies here whenever possible. If you can factor it, factor it. Here, I do not want to see Band-Aid violations here. This is a plus. The only way I'm going to be able to reduce this anymore is if I can happen to take something out of the denominator, which I can. We have a factor of 4 that goes into both. And as I've said time and time again, I'm not pulling the list out again. When you're looking at these, again, we're going to pull the smallest one out, different than an LCD. We don't want to take the x to the third. Because now, I've already got the 4. X times what gets me to x to the third? 2. X times x squared is x to the third. Here, 4 times 3 is 12, and I already got the x. At this point, what's going on here doesn't have a bond. I can whack away. The 4's, see ya. And again, x squared on top, x on the bottom. You can either look at it as there's 2 up here and 1 down here, or 2 minus 1. 2 minus 1 is 1. The larger exponent's on top, so that's where the x has to stay. It does matter. And then keep those parentheses around the x squared plus 3, because again, there's no canceling to be done at this point. Okay, you're set, you're done. With these, you could cancel right away, but I've said time and time again, my favorite here is to just go ahead, multiply straight across, and then reduce the single fraction that's left. At this point I look and I'm like, okay, 450 divided by 150, I put it in the calculator as 3. Bigger values on top, that's where the number stays. Notice a pattern developing here. X's, 8 minus 4 is 4. Larger exponent in the numerator. That's where my x values will stay. Y's, 6 minus 2 is also 4, but the 6 is in the denominator, the larger value, and I'm set. Keep it simple, but factor always. Even if it's just something as small as taking out a 2. Sometimes it may get to be a little more. You're like, okay, I can take a 6 out of these, and that's true. But then can I still factor what's left here? And if you're going, at this point, you need to do about 100 of these at home tonight. Type in difference of squares and get to it. X plus 4, x minus 4. And another difference of squares. Wonder if I'm trying to send a message here. So at this point, once I've factored everything, now I can start whacking away since it's time. So x minus 3's, x minus 4's. Let's see what we've got left. 6 and an x plus 4, 2 and an x plus 3. Can I whack these guys? Absolutely. 6 divided by 2 is 3. It stays on top. Bigger value. That always lets me know where it goes. And that's it. Keep those parentheses around. Do not whack those x's. Drive me out of your... Now we want a flashback to the past on number 4. You're like, ooh, I know it's been a while, but we have done these. Look in each pair and figure out what they have in common. So you're like, okay, I could take an x squared out of here and have an x plus 5. And here, I could take out a negative 1 and have an x plus 5, because the negative would distribute through. You're like, oh, Hardy, I know what this is. It's the one where you take what's outside and put them together, whatever the set of parentheses is. Oh, and then once I factored it, it's a difference of squares. We're going to either get these difference of squares down or we're going to get hammered with them, because they just keep showing up everywhere. What do I square to get each and put a plus minus with it? Dang, he did it again. If you don't know those off the top of your head, I'm serious. You need to Google a worksheet and do like 100 of them. Because at this point, and it's one for one canceling. So like this single x plus 1 cannot get both of those, only one of them. And we're good to go. But you have to completely factor everything. And again, at this point saying, I'm not sure about this and that, we've done lots of all of these. So at this point, we gotta figure it out. Help with the signs. Multiply to a positive means they're both positive or they're both negative. Oops, they're both negative. 8 and 6. Can I take something out? Yep, even if it's just as small as a single little x. Division, it's always the fraction after the sign. So 6x to the top, I can take a 3 out of here. And then whack away. And I've got 6x over, over x. Whack those x's, it's not a strong bond. These are things at this point with the factoring we should just be snapping off like I am right now. It shouldn't be a fact of trying to think about what's going on unless, again, you're going to need more practice at them at that point then. Mental math has got to be a strength when you're doing these and knowing those are both squares. It's like I'm never going to have a problem that doesn't have them. Division, it's just the very next thing that flips. So this is going to be on the top. 6 and 9, 3 goes in, and x squared. Let's see, 2x minus 3. This guy's on the bottom. I take out an x squared, x plus 10. And this guy does not flip, and he is in the numerator because I could make him a fraction by putting him over 1. Whew. Whack away. 2x minus 3, 2x plus 3, x plus 10. Let's see what we got left. X squared is not a strong bond. Whack 'em. Kind of fun when you know what's going on here with stuff. That's going to be the key. Now, perform the indicated operation. Need LCD because now we're adding and subtracting. If it's already that, okay. But please know at this point, I am not nice enough that I'm just going to let you do that and be done. Seriously. Once you get to the end, that's when you can simplify. When it's down to one fraction and it's all ready to go and you're ready to circle it, that's when you start looking for things where you might possibly be able to cancel something like that. Not back when you're building it, which we'll talk about here in a minute. Anytime I see plus or minus, I'm going to put parentheses around them so I'm not silly and think this is the same as that x. And I'm not going to put the other chart back up. Coefficient for an LCD. Do I have one? Yes, this 3. Hanging out by itself. Do I have any single variable terms? Yes, this x. It's not hooked up to a plus or minus. Do I have any quantities? Any sets of parentheses? Yes. I need it all. I need it all. I want it all. I will have it all. And now it's just builder mode, like we've been in for like a week. Got the 3x, need the x plus 6. Got the x plus 6, need the 3x. These are not the ones where you get to wipe out the denominator. That's only with equations, that's only with equals. Oh, please, 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 please don't do that on these because I will deduct points. So I look and I'm like, okay, I'm going to distribute. The more work I show, the better, because then if something goes haywire, at least maybe I can get some partial credit. Let's see, 10x plus 24. Does anything come out of this? This is the time I can look for stuff. Well, I can get a 2 out. Let's see if that helps me. Is there anything not in parentheses that can reduce? Nope. Oh well. That's life. 9, get those parentheses working again. My LCD. Coefficients? Nope. Single variable terms? Yep. Parentheses? Yep. Do I need squared on the x minus 2? Nope, they're not in the same fraction. Already got the x squared, already got the minus 2. I don't need anything. If you want to desperately put something, put a 1. Here, I got the x minus 2. I need the x squared. 5 plus x cubed over x squared, x minus 2. Put that in parentheses 2. You cannot whack those. You whack those will be a major deduction because we've gone over that a whole lot. That's all I'll say about that. I'm going to keep factoring away. Factoring well keeps Hardy from ringing your bell. Okay, yep, getting goofy again. All right, LCD. No lonely variables, no coefficients. I just need my quantities. Do not stop. You are a fraction builder. Got the x plus 4, got the x minus 9. I don't need anything. I'll just use the 1 because I want to write something. Got the x plus 4, need the x minus 9. And we go into simplify mode. 2x squared, oops, I forgot the 18x, plus 2x squared minus 18x over all this good stuff. Hey, 18x minus 18x. All right. 2x squared. Nothing cancels because they're in parentheses and that's not. Seeing the pattern here. Seeing the pattern, people. And that's what this is. It's all about. Do you know your factoring? Do you know your 3 parts to building an LCD? And then can you just fraction builder mode? If you've got those things, great. If not, watching this video, watching the last quiz previews video, or any of the lessons would get you what you need to do. It's all dependent on what you are going to do. Nice, and give you another one with a common denominator. Am I just going to let you combine those like terms and be done? Heck no. What do they have in common? 4. What do they have in common? X. X plus 6. What a coincidence. Not really. When you can factor, this stuff is easy. Difference of squares. Factor first. LCD, 2x plus 1, 2x minus 1. First fraction. Got it all. Good deal. Second fraction. Just need the 2x minus 1. And here's where the one caution will come on this problem, and it's something that's gotten some of you for a half point here and there. Remember, this minus goes to this 2 and distributes, and we've talked about making this negative 2 and turning that plus. So I remember that. Combine like terms. None of my parentheses match up. Good. This is like the no screw around zone. Parentheses. Solve. Now is when we build the LCD and then wipe it. LCD. Coefficient. Lonely variable. Quantity. We are off and rolling. Cool thing is later you'll be able to actually pause me if you need to for a minute. Now, well, unfortunately you can't. So, all right, piece by piece. I have the x, but that's it. So I need the 2, and I need the x plus 1. Here I've got the 2x as a whole. I need the x plus 1. Here I have the x plus 1. I need the 2x. And again, the equals is the key. If you have equals, now once you build, you can tell that to go away. 7 times 2 would be 14. Then I'm going to multiply through by with my x plus 1. So 14x plus 14. 6x plus 6 when I distribute, plus 6x squared. And we've talked about this before. Whichever side has the x squared is where everything goes. So the minus 14x minus 14, 0, 6x squared minus 8x minus 8. Factor till you can't no more. Take out a 2. 3x squared minus 4x minus 4. Can I factor what's inside? What do you think the answer to that question is? Yeah. Sliding dividers, I'm not trying to short you here, but we have a time issue to play with. So I'm actually going to just factor this out. And then we set each of those sets of parentheses equal to 0. Double check and make sure. It'd have to be 0 or negative 1. Nope, we're good. That's a little bit messy. LCD, x plus 3x minus 3. I got a hint coming for you on this one to help some things out and maybe save you a little bit of work. Won't be able to do this on every single problem, but on one like this it'll come in handy. Okay, first one, I've got everything. You're like, woo, you're moving. Talk some more, so you'll slow down for a second. Okay. Chekarooski. I'll stop and talk here for a minute when I'm getting to my clue. Oops, I wanted to keep that in red. Now I get to the end. And you're like, okay, I need everything. I need x minus 3, I need x plus 3. Well, what does x minus 3, x plus 3 multiply out to? Multiplies out to what we scribbled out here before, which is x squared minus 9. I'm actually going to use that because when I'm multiplying through, I don't want to have to multiply this through again. It could mess me up. So I'm going to leave that. It's the one time I can do that. Do a little distributing. And that 1's not going to change much, but I have an x squared term. Everything's got to come over. So 9 minus 9. So I'm going to minus the 18. I got x squared plus 3x minus 18 equals 0. Factor that sucker. And again, I'm not trying to do the fast thing to drive you crazy, but I'm just telling you, at this point, you need to be able to whip through these. And then don't forget to go back, because if you have a number that causes a 0, uh-oh. 3 minus 3, denominator of 0, bad. The other one's fine, though. Little stuff, little stuff, little stuff. Are these the same? We've talked about this a bunch, too. No. Can they be made to be the same? Yes. How do I do that? Well, I can pull a negative out of here. Now when I pull that negative out, I can do a few things. What I like to do is I send that negative up to the numerator. And then I just switch signs. The 4 became negative, the x became positive. If you wanted to put the negative right in front here, you could. But again, I don't need an LCD this time anyway, because I'm just going to cross multiply because they're single fractions. So get that set. You're like, okay, Hardy, now here's a new one for us. Not something we haven't seen before, but it's been a little while. You're like, oh my gosh, x cubed, you're freaking out. Don't freak out. Get everything to the x cubed side where the biggest stuff is. There's no need to panic. It's going to take care of itself in a minute here. You just have to be patient. You're like, be patient, it's still there. Not for long. What do you mean not for long? What do all three of these terms have in common? XO. Freaked out for nothing. Factor what you've got left. This is different than just a number. X I can actually set equal to 0. Oops, excuse me for a second. So 0, set that equal to 0 would be 4, because I'd add it to both sides. And negative 2. Did any of these cause a problem? Yes. 4 minus 4 is 0. 2 answers. And again, this is all stuff we've been going over a lot for the last couple of weeks. And then finally, solve each equation. We're sticking with our simpler one that we talked about in class. Our 1 over t, and then adding our 2 individual times. So John can paint a fence in 6 hours. Deshawn can paint it in 7. What if they work together? Multiply these three values together, which would get me 42t. And like we were talking about in class when we did these, if you're more comfortable then when you distribute the 42t through, just putting the 42t on top of each of those fractions so you can visually see how it reduces. So on the one with t, it just cancels out the t. 42 divided by 6 is 7, but the t doesn't go anywhere. 42 divided by 7 is 6. T doesn't go anywhere. And then I just go ahead and divide. I'll do it on here instead of pulling up that calculator on you. Take about 3.23 hours. Much better use of time than spending like 6 or 7. And your answer, of course, is going to be less working it together. Here, be careful. Perry can pick 40 bushels, well, 9 hours. The 40 bushels is kind of a trick. One day his friend Michaela helped him. And it only took 3.94. Anything looking familiar yet? Ooh, I got to get this time. That's true, but I still need to multiply my values together. If some of you are sitting there going, where's the 35.46 coming from? Multiply these together, you'll find out. And then again, I'm going to take this and just divide by each of these. So 35.46 divided by 3.94 is 9, but it doesn't cancel out the t. 35.46 divided by 9, you'll never guess. 3.94. Again, the t doesn't cancel. The t doesn't cancel to this last one where all you have left is the 35.46. Subtract your other t value over. And we're going to divide, and we are going to be done with this. Okay. This, ladies and gentlemen, is your unit test for tomorrow. There might be a couple of things I slightly twist, but this is basically it. So this review with some explanation stuff took about 25 minutes or so. With the homework check, you're still going to have plenty of time to work this through. So if you have questions, get them answered so we can have a good one. See you later.